You have trained a model. Now comes a question that has nothing to do with accuracy, and everything to do with engineering. When, exactly, should the model run? There are two very different answers, and choosing between them shapes your whole system. Here is the trained fraud model. The same weights, the same math. We can serve it in real time, the instant a request arrives, or in batch, scoring everything later, all at once. Let's walk through each, honestly. Real time first. A card is swiped this very second, $300, 3 in the morning, far from home. The request flies to the model, and a customer is standing at the terminal. The answer has to come back now, not tonight. So the model scores this exact swipe, live. Watch the fraud probability climb. 97%. That crosses our threshold, so the decision is block. One transaction, one fresh answer, computed on demand. But that answer isn't free. Every stage of the round trip spends time, and it all counts against a budget. The network in, validating the request, fetching the customer's features, pre-processing, the model score itself, barely a millisecond, then the response back out. Add them up, about 42 milliseconds, start to finish. 42 milliseconds is the typical case, but under real load, requests pile up and wait in line. The slowest 1%, the P99, can balloon to 120 milliseconds. In real-time serving you design for that tail, not the average, because that's what your users actually feel. Now the other way. Instead of waiting for each request, we score everyone at once. 50,000 transactions go into the model in a single pass, and out come 50,000 scores. This runs on a schedule, overnight, say, with nobody standing there waiting. What does that job cost? Let's break it down. Starting up and loading the model, reading all the features in bulk, then pre-processing and scoring all 50,000 rows, and finally writing the results. About 13 seconds in total. And notice, the scoring step is the tiny sliver. Almost all the time is spent moving data, not doing math. Why is scoring 50,000 rows so cheap? One word: vectorizing. If you score one row per Python call, the interpreter crawls through them one at a time, slow. But hand the whole array to the model at once, and it finishes in a snap. On a real machine that's dozens of times faster, and it's why batch throughput is so high. So let's turn that into a rate. 50,000 rows divided by 13.2 seconds is nearly 4,000 rows every second. Compare that to serving the same 50,000 one at a time in real time, about 35 minutes. Batch does the identical work roughly 160 times faster, because it pays the fixed costs once. So batch always wins? Not quite. There's a catch, and it's freshness. A score computed at 2 in the morning and read at 3 in the afternoon is 13 hours old. If the customer's behavior changed since then, you're deciding on stale information. Real-time rescores on the spot, always fresh, but you pay for every single request. So which do you choose? Match the tool to the job. A nightly credit risk report? Batch, freshness by the hour is fine. Blocking a fraudulent swipe? Real-time. You have milliseconds. A recommendation feed often uses both. Pre-compute candidates in batch, then re-rank them live. So, to recap, real-time serving is fresh, but every request lives inside a tight latency budget, tail and all. Batch gives enormous throughput because vectorizing makes scoring nearly free, but its answers age. Choose by how fresh the prediction must be, weight against cost. Sometimes the right answer is both. Next, we'll wrap a model in a prediction API so anything can call it.